This video is provided as supplementary material for courses taught at Howard Community College. And in this video, I want to talk about finding the least common multiple, or LCM, of 3 or more numbers. So here's the first problem. I've got to find the least common multiple of 28, 30, and 35. Now, I could do this with prime factorization. I could make a factor tree for each of the numbers to find the prime factors. And then I could take all of the prime factors of the first number, of 28. I could put those into a list. And I could add any prime factors of the next number, of 30, that were not already in the list. And then I could add any prime factors of 35 that were not already in the list. And if I multiplied all those numbers together, I would get the least common multiple of 28, 30, and 35. But there's a much faster way. Here's how it goes. I'm going to write those three numbers, 28, 30, and 35. I'll write those left to right. And I'm going to put a kind of an upside down division box around them. And now what I want to do is see if I can divide any of these numbers by a prime number. Well, since 28 and 30 are both even, I can divide them both by 2. So I'm going to write a 2 to the left of the box, and I'll divide. I'll divide 28 by 2. 2 goes into 28 14 times. I'm going to write a 14 underneath the 28. 2 goes into 30 15 times, so I'll write a 15 under the 30. 2 does not divide into 35, so I'm just going to bring down the 35. And now what I'm left with, 14, 15, and 35, these are composite numbers. As long as I've got composite numbers, or duplicated numbers, I'll get to that later, I have to repeat the process. So I'm going to draw another box, and I'll see what I can divide by. Well, I could divide, let's say I've got 14, 15, and 35. I know I could divide 15 and 35 by 5. So I'll put a 5 to the left of the box, and I'll divide. So 5 divides into 14. Well, it doesn't divide into 14, so I'll bring down a 14. 5 divides into 15 3 times. I'll write a 3 under the 15. And 5 divides into 35 7 times, so I'll write a 7 under the 35. Well, 14 is a composite number, so I've got to divide again. And I can divide 14 by 2. I can't divide anything else by 2, but that's okay. So I'm going to write a 2 to the left of my box. I'll divide. 2 goes into 14 7 times. 2 does not divide into 3, so I'll bring down the 3. And 2 does not divide to 7, so I'll bring down the 7. Now I've got prime numbers in the bottom, but I've got 7 and 7. That's repeated. So I'm going to start again. I'll draw another box, and I'll divide out that 7. So 7 goes into 7 one time. I'll bring down that 1. 7 does not divide into 3, so I'll just bring the 3 down. And 7 divides into the other 7 one time. Now I've got prime numbers along the bottom. The only thing I've got repeated on the bottom is 1s. And I've got prime numbers along the left side. All of those prime numbers multiplied together are going to give me my least common multiple. I'm not going to worry about multiplying the 1 into it, the 1, because 1 times anything doesn't change its value. So my least common multiple is going to be, let's see, I've got 2 2's, so that's 2 times 2. I could have written 2 squared. Going in order from the smallest multiples to the largest ones, I've got a 3, and I've got a 5, and I've got a 7. So the least common multiple is going to be 2 times 2 times 3 times 5 times 7. And I could multiply all of those together and get one single number that was the least common multiple. But instead of doing that, I want to do another problem, this time with the least common multiple of 4 numbers. Remember, you can do this for any number of numbers. You could do it for 2. You could do it for as many as you want. So I've got the least common multiple of 14, 20, 30, and 21. So I'll write those four numbers, 14, 20, 30, and 21. I'm just writing them left to right. I'll put that box around them. And let's see, 14, 20, and 30 are all even. So I'm going to divide out a 2. I'll put a 2 to the left of the box. 2 divided into 14 goes 7 times. So I write a 7 under the 14. 2 goes into 20 10 times. So I write a 10 under the 20. 2 goes into 30 15 times. So I write the 15. And 2 does not divide into 21. So I just bring down the 21. I've got composite numbers here, 10, 15, and 21. So I'm going to start again. I'll make my box, and let's see. 10 and 15 are both divisible by 5, so I'll divide out a 5. So let's see, I've got a 5 next to the box. 5 divided into 7 does not go, so I'll bring down the 7. 5 goes into 10 2 times, so there's the 2 underneath the 10. 5 goes into 15 3 times, so I'll write that 3. And 5 does not divide 21, so I'll just write down the 21. We've got 7, 2, 3, and 21. 21 is a composite number, so I have to keep going. And I could divide 7 by, I could divide 21 by 7 or 3. I'll go for the 7. It doesn't matter which I use. So I'm dividing by 7. I'll write 7 to the left of the box, and I'll start my dividing. 7 goes into 7 one time, so I'll write the 1. 7 doesn't divide the 2, so I'll bring down the 2. It doesn't divide the 3, so I'll bring down the 3. It divides into 21 3 times, so I'll write a 3 underneath that 21. Now I've got no more composite numbers, but I've got a number duplicated. I've got a 3 and a 3. So I've got to divide out a 3 from what I've got here, from the 1, 2, 3, and 5. So I'll write a 3 next to the box, and I'll divide. 3 doesn't divide into 1, so I'll bring down the 1. It doesn't divide 2, so I'll bring down the 2. It divides into 3 one time, so I'll write down that 3, and once again it divides into 3 one time. So now I've got prime numbers along the bottom. The only thing duplicated is the 1s, and they don't matter. I've got prime numbers down the left side. So all of those prime numbers are going to be what multiply together to make my LCM. So the least common multiple is going to be, let's see, I've got 2 2s. So I'm going to write that as 2 squared. And a 3, a 5, and a 7. So it's 2 squared times 3 times 5 times 7, which is actually the same least common multiple I got for the last problem. Okay? So basically that's how this process works. It's really useful if you've got a lot of numbers to find the least common multiple of all at the same time. Or you could do it for 2 if you prefer this more as opposed to the prime factorization method. Okay? So that's it for now. Take care. I'll see you next time.